Hi, Earth Science students. It's Mr. Gopal here, and today I want to talk a little bit about topographic maps, how to understand them, and glean information about a geographic area from them. So the title of this lesson is Mapping the Earth, and our focus question is how can we use our knowledge of maps and measurements to design a topographic landscape? And it's part of our first unit on maps and measurement, and it's day 17. In this particular lesson, we want to be able to analyze what we call a contour field and locate both bodies of water and hills. We'll locate those using the same sorts of hints or clues from the structure of a contour map. We want to determine a scale, give a compass direction and elevations for a contour field, and then practice skills for calculating contour intervals and what we call gradients, and then drawing profiles. So when we start off, we have this really funky looking map here. And it might sound strange for me to call it a map because it doesn't look like we have any geographic information from it. This is contour art, all right? And so it hasn't been turned into a map yet because there are many key components of what makes a map missing from it. For example, we don't know our ordinal directions. Nor do we understand in terms of, I guess, types of land masses and water bodies, what it is that we're looking at. So our first step would be, how do we envision north? And that would be the same way that we always tend to envision north, south, east, and west. And that would be by drawing a compass. So I'm going to draw it just off of the edge of the map so it doesn't kind of obstruct our view of anything going on here. So I'm going to put it right here on the left-hand side of the map if you're facing it. I'm going to put it in the bottom corner so you can see down there. I've got our compass. All right. Usually we see a circle around these. And now I'm going to write our directions. I'm just going to sketch them with the draw tool. Here would be north pointing up, down would be south, left would be west, and right would be east. Okay, and those are going to be standard whenever you have any kind of map. All right, so now we know up here is north, or our northernmost point. Over here is our westernmost point. Down here is our southernmost point. And over here is our easternmost point, all with respect to this map. Now, what we need to understand about contour maps is that the information that we're getting is about the elevation of the geographical area. When I say elevation, what I'm saying in reality is how high or low a certain point on the map is with respect to sea level. Sea level is our great reference point because all points on land are at some point above sea level, unless they're at the very edge of the shore, like the shoreline, because depending on where the tide is at, that particular point may be over or under sea level. For example, if we have a low tide and the tide is farther out, we can see more of the land, all right? And temporarily that land is above sea level. However, we wouldn't mark it as above sea level or at sea level normally because high tide tends to wash over it at certain points and it gets submerged underwater. So here we have an area that's well above sea level. And the reason I can tell is because each one of these squiggly lines stands for a certain point above sea level. Okay, so let's say, I'm going to change the color so it really pops. Let's say we're talking about this area right here. Okay, I'm going to roughly outline that. The reason I chose this area is because, as you can see, there are many successive squiggly lines that all encircle the next ones. All right, so as I'm going up and the dots that I'm making, we can see that each one of those lines is completely surrounded by the previous line. And what this means is that this area is going only higher and higher up. Let's say that I added a particular value to the distance, the vertical distance between each successive contour line. And I want to make this intelligible. So I'm going to say, okay, the value of a contour line. So I'm going to say the value of this contour line equals 1 kilometer. Okay, and that would be above sea level. Okay, and so for this outermost point, we have lines now running out into others. I'm going to change the color so we can see that. Out here, this line actually goes over that way, like so. All right, and so we can tell, since there are so many more lines inside the red area, that entire red area is pretty much higher than this blue area. All right, and so when we're thinking about bodies of water, we know, for example, if we're thinking about the Grand Canyon, we know that the Grand Canyon has a river that's far below the top of the canyon. Okay, so where visitors and tourists stand when they look over the Grand Canyon, it's so impressive. I visited recently and it's unbelievable. We know that the river is far below where you're standing when you stand over the canyon. All right, and so maybe these dots that I draw, these red dots going inward, would represent around that highest point where we're overlooking the progress of water. So in other words, when you're analyzing a contour map, what you want to figure out about where bodies of water, or if you want to figure out where bodies of water are actually traveling, then you want to look for these lines not being surrounded by many more lines. All right, all these areas, there's another one down here, I'm going to mark it in blue. This general area over here, we can see that there are many lines inside of others, which means that the elevation is increasing upward. On the other hand, if we get to an area like this, I'm going to mark it in green, we get to somewhere like here or here, and there are no more lines inside, but those lines are surrounded by many other lines, then we know that the green areas are, I guess, the tops of hills, or you could say the tops of mountains, depending on what we're looking at, and the change in elevation. If I have 1 kilometer, that's pretty significant. If we were hiking up from the outer red area all the way up to the green area, then we'd hike up, let's see, 1, 2, 3, 4, 5, 6 kilometers, which is pretty far. For reference, let me see, they're about 1.6 kilometers in a mile. So 6 kilometers would be 1.6 times 6, which would end up being about almost 10 miles. Okay, so we would hike very high above where we started, which I'm going to mark in orange. We'd start around here. Okay, so the basic idea, and I'm going to put it on the side, is that contour lines that are not surrounded by more represent usually bodies of water or places of low elevation. Okay, elevation meaning vertical distance above sea level. On the other hand, contour lines surrounded by many contour lines represent tops of hills or mountain tops. Put on a new line. In other words, places of high elevation. And this is the way that we read a contour map. All maps tend to give us some information while obscuring others. For example, if we just look at the map of the 50 states of the United States of America, the information that we're getting from there are the states' names, perhaps the capital, the names of the capital cities of each state, and then any other large and important cities. For example, if we're in New York, we have to mark New York City because it's such a large and important city, even though it is not the capital. Hopefully you know that the capital is Albany. In a contour map, we're not going to get that information about important places and names, because all they want to focus on in a contour map is the actual change in elevation of the geographic area that's being mapped. And so, again, we look to these points that are not really surrounded and seem to be outside of these like concentric squiggly lines. and those would be bodies of water or places of low elevation. And on the other hand, the places that are surrounded by many contour lines, well, each contour line represents all the places that are connected by that line, represent all the places in that local area that are a certain level above sea level. So the more that we have them inside each other, the higher it is. So we're going up like 6 kilometers from the bottom to the top of that green area that I mapped with the green kind of hopping line. Okay, so those are the basics of it. Now we're going to take a look at the next slide. So on the next slide, we get a light introduction to some of the features that might be on a Regents type question regarding contour maps. So we can see now with this light blue top left corner that we have a contour map of an area at the edge of land where the sea begins, okay? And so they ask, what's the value of contour line C? Hint, it is at sea level, or it is sea level. So yeah, they're giving us that answer, and you might ask yourself, well, wait a minute, there's a chunk of land sticking out like here in between that contour line and the sea. And so what about that? If we're mapping it, doesn't have to be above sea level. Well, this is the exact part that I'm talking about, all right, that changes relative to the tide. So at times of low tide, this land would be exposed. However, we can't say it's above sea level because at high tide, we wouldn't see that piece of land. It would be covered by the sea. So let's say we created a contour interval for this map. Let's say that well, this time I'm going to say that each contour line, and I'll mark it in the same color that they do, roughly, each line is going to represent 2 kilometers this time. So that means if we start here and at sea level, this is 0 kilometers above sea level. Let me change the color so you can see that a little bit clearer. This right here, oh, I can do better. This right here is going to be at 0 kilometers. And then that means that all of these places along this line are also at 0. On the other hand, if I hop one contour line, I should have gone up 2 kilometers according to the scale that I just created. So everything along here is 2 kilometers above sea level, and so on and so forth. I am just going to mark the numbers from now on. All right, I'm going to use red again because it kind of pops on this screen. So this would be 4, 6, 8, 10, and then at B, I'm going to get to 12. All right. On the other hand, if I look at this area where D is, where I'm circling my mouse, I can see that that's outside, but I still have the contour line C tracing around here. I'm going to trace along with it. So all of that's at 0. So this is at 2 again, and here is 4. Okay, so D would probably represent a smaller hill, whereas A and B are the tops of much higher hills. So you can see A has the same amount of contour lines surrounding it as B. So this would be at about 12 as well. All right, and then this little patch here, well, that's between, let's see, this is still 8. And this is 6, so this would be at 10, but there's a depression, okay? And when I say depression, what I'm talking about is elevation down, elevation traveling down. So sometimes, obviously, if we walk up hills, they don't just go straight up uniformly. Sometimes they move a little bit down and then go up again, all right? Just because of weathering, erosion, and other geographic factors, the movement of tectonic plates, it all gets very complicated. And these are things that you're going to encounter as you understand geographic spaces in more detail. But what they've done in certain scenarios is they've given you tick marks, okay? And so these tick marks, and I'm going to circle in, let me see, green, these tick marks represent parts of the map where there's a little bit of a depression, even though the overall elevation is going up. So we are going up. This is 0, so right here is 2. That's 2. And let me erase and move 4 because this map is just a little bit different resolution. than the one on the previous page. So here's 4, but right between here, there's almost like a dip down before we go up even higher, up to 4. Now, you don't always see lines. Sometimes you have to create them on the regions based on information that you're given. So if I look to the next slide, I can see that instead of contour lines, what I'm given is an area with a river and a lake, and then a series of numbers. What I have to do is I have to find the points where I can connect numbers to other numbers of the same value. So if I were to start, let's say that I'm going to start at a really high number, because the higher number means the higher elevation. I can see that I have a 50 elevation on the outside. So I'm going to look for some of the highest numbers I can find. Here's 78. All right, so 78, I have to connect that there, and here, and here. Now 78 is not going to quite connect with 79. 79 is bigger, so I'm going to go outside of it. And then I'm going to go straight through this one. And then let's see where we can go from here. Everything above it looks a little bit lower. So this is going to be a very thin line. Can't touch 75, should probably be even farther away from 70, and so on and so forth. All right, it's going to be far away from 75, and then it's going to extend over to here. 79 is a bit higher, so I might have a small circle in there, and then I would look for 77, which is out here, and do the same process. Now, I'm not going to draw all of 77, but we can see that there's a large break. I'm going to draw it in a different color between 77 and 78. And that means that the incline is very gradual. On the other hand, right here between 78 and 79, very small bit of area between them, which means the elevation happens much more rapidly than at this point. And so that means that there would be a less dramatic gradient. Our gradient is like our grade, okay? So perhaps if you've ever driven on certain country roads that are going up to a high elevation, they might tell you the grade of the road if the road is rather steep, okay? And usually they give it in percentage points. So what's going on in that case is that you have, I guess, a slope of a road relative to a flat road. And they're giving you that information so you can prepare yourself and drive very carefully, because sometimes it can be treacherous when you're driving on very steep roads. Okay, so we have a small gradient on the right-hand side over here. I'm going to circle it in blue. And then on the other hand, in orange, we have a very steep or large gradient over here. So this is my introduction to contour maps. In it, we covered the idea that a map does not actually give you all information possible it can about a geographic space, because that would just be an information overload. It would be very hard to read. Contour maps specifically deal with the elevation of a geographic space. By looking at contour lines that are surrounded by many other contour lines, we can find points of high elevation, like the top of a hill or a mountain. And by looking at contour lines that are outside of all of these other contour lines that are surrounded, we can find points of low elevation, which might indicate a river, body of water, or the bottom of a hill. In addition, we can design scales, and we can add a compass in order to get a little bit more information that orients us on a particular field that is being described by a contour map. I hope that demonstration helps you answer questions about contour maps, and I will see you soon.